Hello everyone, it's 1 p.m. Eastern, and that means it's time to start up our monthly CoCoRaHS WxTalk Webinar. We're back with you once again after a 6-month vacation, and the webinar really enjoyed that time off, and we've got a great lineup coming up this fall, which includes a look at lake effect snow and our very own southwest monsoon here in the United States. We'll have that and details for you on our website on those later on. Well, thanks for joining us today. I'm your host, Henry Regis. Running the technical side of our program today is Noah Newman, and we're coming to you live from the Colorado Climate Center here at Colorado State University in what was sunny and now is a little cloudy Fort Collins, Colorado. For those of you unable to join us today for our live broadcast, we'll be recording it for future viewing on our website. And all of our WxTalk webinars are sponsored by grants from NOAA's Office of Education and the National Science Foundation. Well, during today's webinar, we're going to explore the history and uses of volunteer weather observations in the U.S. And who better to present this than Colorado State climatologist, my colleague, and our very own founder and director, Nolan Duskin. Nolan, welcome.
Hello there. Good morning.
Well, weather observations. I have an inkling you know a little bit about this subject.
Well, I have been dabbling in weather observations, and I'm going to cover today both a little bit about CoCoRaHS, but a whole lot about things that came before. And I'll wait just a minute while we're getting it ready to go online, and we'll.
Now let me ask you, Nolan, you've been a weather observer. How long have you been observing weather? From your childhood, right?
Yeah, my dad had a little window thermometer, and he kept a logbook from the time I can remember. And then we had a little garden rain gauge, and before I went off to college, I found this fancy 4-inch diameter high-capacity plastic rain gauge, and I bought him one in 1969 or 70, and that's actually the early days of the same rain gauge as we use today in CoCoRaHS.
Wow, that's pretty cool. Well, listen, I'm going to turn it over to you now for your presentation. We'll take questions afterwards, and thanks again for doing this.
All right. I hope everybody can hear me okay. I'm ready to roll. We're going to go back in history today, looking at both the background of volunteer weather observers and observations in the U.S. There's certainly history in other parts of the world as well. But we're also going to dabble a little bit in how the data from volunteers get used. And again, it's an honor to be the presenter of WxTalk Webinar number 40. Henry, thanks for organizing and keeping this series going and getting it rolling again. I wanted to give some credits here for the presentation I'm about to give, because we had to do some historical explorations utilizing some of my contacts and colleagues in NOAA and other state climatologists. There's the list of names right there. This was a presentation, part of this presentation was put together for our annual meeting of state climatologists this past summer. And I wanted to draw to your attention some interesting resources that some of you history buffs might want to dig into if you want a little more background about the National Weather Service Cooperative Observer Network. And again, we're not going to talk in great detail. I do love the book, Meteorology in America, 1800 to 1870, and that's Jim Fleming. Some of you may recall gave a webinar, I can't remember which one, fairly early on in our sequence. He's a historical meteorologist and was actually a graduate of our department here, Department of Atmospheric Science at CSU, and then did a left turn towards history and has been doing weather history ever since. This year, and I believe this was one of my quiz questions when you signed up for the webinar, this year the National Weather Service is celebrating 125 years of their volunteer observer network called the Cooperative Observer Program. But in reality, weather observations, volunteer observations go back much farther. The 125-year threshold is really quite an arbitrary one, but it happens to coincide with the formation of the U.S. Weather Bureau. which consolidated some of the early observation networks into a singular one called the Cooperative network back in that 1890-1891 time frame. Quite frankly, as long as there have been humans, there have been volunteer weather observers, because weather and its variations has always been compelling, fascinating, and in fact life-saving. The more early people knew about the weather that was coming and likely to come, no matter how they could piece that together, the better their chances of survival and thriving on this planet was. But let's start with some of the familiar faces in weather observations. And I want to start with a very famous fellow here by the name of Ben Franklin, known for some of his wise sayings, but he was already out actively recruiting, and I can't remember, Henry, you might recall, when was he postmaster, but he was recruiting among the local postmasters of the early colonies and also shipmasters. He was looking for people willing to measure and report weather conditions, knowing that that was something very important for transportation and delivery of mail back then. And then, of course, a very famous early observer by the name of Thomas Jefferson, with himself over 50 years of dedicated weather records, not just thinking about it and talking about it, but in fact writing it down, keeping duplicates. My guess is that there are probably dozens of you on this webinar today who have been to Monticello, and you may well have seen his reporting system there and some of his old logbooks. Just amazing. And he was already interested in networking. He and Ben Franklin would compare notes on what their conditions were on the same day at the same time. They were trying to get a handle on how to improve weather forecasts for the benefit of our early country. The first really systematic network, and it wasn't quite volunteer, but we had most of the early forts, and we had a system of forts across our country from coast to coast, starting all the way in the 18 teens, and the Post Surgeon General was requested to record weather observations, and the organization gradually made more systematic procedures and established some standards and some forms for reporting. Again, not quite voluntary, although not all post surgeons in fact did it. But it was our first written records, and some of these records can be seen, found, and have been logged and made publicly available here in a data recovery effort in the last few decades. A true champion for public participation was, in fact, the very first secretary of the Smithsonian Institute, Joseph Henry. I've been reading a book about John Wesley Powell, and turns out he and Joseph Henry had many, many conversations as they attempted to lay a foundation of geology and climatology for the country. And he, in fact, Joseph Henry, envisioned a network of volunteers that would allow a better documentation of what the climate resource of our young country was, and in fact form a basis for early weather forecasts. And they started their first meteorological project back in 1849, and it grew to as many as 600 active participants at any given time at its peak, and then had a hard time surviving during Civil War, but did in fact continue, but with much reduced numbers. And then is where our Joseph Henry was in fact working hard to bring technology to bear, bringing in the modern internet of the day, which was the telegraph, for sharing information instantaneously. And there is a graphic commissioned for the Chicago Century of Progress exhibit back in 1933. And I believe, is that true? Yep, my mother was there. And this was not in the picture, but she was in Chicago around that time, and trying to show this great progress in weather prediction and monitoring. It took, amazingly, 12 years from when the first bit of data collection began before any information was available for the participants. So if you were a volunteer back in 1849 and you wanted to see your data analyzed and put in context with the other observations being collected, it took till 1861 to get that first compilation put together. But we were a lot more patient back then. Big transition occurred in 1870. That's when Congress passed a bill giving the Army Signal Service, part of the War Department, responsibility for storm and weather prediction. It was not civilian, it was military, and at that point, from the very beginning, they put together an observing network, first of paid staff who were in fact military officers, and then later they too began an effort to start a volunteer network. That picture you're looking at was in the early 1870s on the top of Pikes Peak here in Colorado, over 14,000 feet high. How's that for a facility back that far back? And my guess is some of you have been to the top of Pikes Peak. As that part of our history began to evolve, the old Smithsonian Meteorological Project was retired, but public participation did not retire. And then gradually in the 1870s and 1880s, many states founded their own state weather service. And here in Colorado, it was in the mid-1880s, a $2,000 appropriation from the state legislature from our very young state, less than 10 years old at that time. And an effort was immediately established to start a volunteer weather observing program. Many other states already had it at that time or were in the process of doing that. And I just want to bring here one of the earliest pictures of our cooperative weather station here in Fort Collins. This building no longer exists. It burned down during war protests, Vietnam War protests in 1970, sorry. But there, if you look closely, in the far left corner of that early photograph of our first and only campus building was the weather station. Aha, wonderful. Here's just a map of Colorado, but every state had a map like this back from 1890, vintage, and it was the volunteer network as it was constituted by that time. So already by 1890, weather stations mostly measuring precipitation in a similar way as we do today, but with a larger metal rain gauge. But many of these stations were also equipped with thermometers. And between the thermometer and the rain gauge and the eyes of the observer and standardized methods and forms for reporting, volunteer data collection began that we continue to this very day. And it was the U.S. Department of Agriculture took over that responsibility from the U.S. Signal Service, and the civilian National Weather Service was founded, and right along on the heels of that formation came the Cooperative Observer Program. Now, I think I asked a question as you registered of when did we peak? When did the number of volunteers in that cooperative network reach its peak? And you'll see it was in fact in the early 1950s. And there's some artifacts in these records. There was really a more gradual ramp up from 1870 into the 1890s instead of that instantaneous jump in 1893. That was when record keeping began in a more earnest fashion. And likewise, there were some artifacts there in 48 when more early digitization of weather data began, and then 1951 when we dropped some of the recording weather stations using weighing rain gauges. But that gives you a hint. The volunteer program within NOAA has been strong and significant for a long time. And behind every one of the data points on that graph, which peaked over 10,000, it's now a little over 7,000, closer to 8,000. But behind each of those dots is a story. And our own weather station here in Fort Collins participated in most of these record-keeping epochs. The Army medical records, again, 1800s to 1870s, Smithsonian project, 1840s to 1870s, U.S. Signal Service, 1870 to 1890, state weather associations from the 1870s or 1880s into 1890-91 time frame. Then the Department of Agriculture, U.S. Weather Bureau, 1890 to 1940. Then the Weather Bureau was transferred to the Department of Commerce in 1940, still called the Weather Bureau, but then changed its name in 1970 to the National Weather Service, which it is today, and it's still within the Department of Commerce and still maintaining a volunteer network called the Cooperative program. And just again, loving history and getting to tell a story of our own Fort Collins weather station. That was our first official observer. We found a little bit about him. He had in fact signed up under the Smithsonian network that he was familiar with, where he had lived in Kentucky before moving to Colorado to experiment with irrigation and irrigated farming. And then many stations have either well-known characters or in fact a few famous observers. In our case, in the late 1880s, one of our weather observers here was Elwood Mead, who went on to become the commissioner of the U.S. Bureau of Reclamation and had a very large reservoir there above Las Vegas, Nevada, Lake Mead, named after him. And it's amazing to go back and find that he was in fact doing the reports, filling out the forms, and sending in data. Most of the cooperative observers, most volunteers are good, just regular folks, but we do have a combination of a few famous and a few very infamous observers here and there throughout the records. Just to show that times change, this was a few years after our weather station was founded, and now you'll see there's the expanded weather station with some new buildings between us and the foothills of the Rockies. And there was one of our illustrious observers from the 1930s and through the 1950s, Maxwell Partial, showing off the mercurial barometer and the weighing gauge. And his house still looks, he's long since deceased, but his house still looks almost just like this, just a few blocks from where the campus weather station is today. We've tried to track down his daughter, who would be in her 70s or 80s now. We have not succeeded. We would love to hear stories from her of her dad's weather observations. And time passes. Maybe somebody is on the webinar who was in the picture here. These were some of our grad students when I first took responsibility for the weather station in the early 1980s here, and we were removing one large weather shelter which was taking up a lot of space. But that was, by the way, what I looked like a little over 32 years ago. Time does take its toll, doesn't it? And that was the picture of the weather station, and that it still looks largely the same, but buildings in the background have changed, trees have grown, a few of things have changed, but for the most part our layout and instrumentation is just about the same as in that picture. And there's a more modern picture while we were, let's see, can we see it? There's the CoCoRaHS rain gauge right there. There's the National Weather Service 8-inch diameter standard rain gauge, probably 100 years old or older. There's the same recording rain gauge as you saw in the picture with Maxwell Partial, There's an evaporation pan. Those of you who are National Weather Service cooperative observers, many of you use the maximum minimum temperature system. We have that, but we continue to use, as we have for most of the 125 years, over 125 years, liquid and glass thermometers inside our weather shelter there. We can go into some detail, but as of recently, each data point on this map represents the National Weather Service's volunteer network as it looks in the 21st century. You'll see higher densities in some areas, lower densities in others, but overall a marvelous nationwide volunteer network. And now we're about to show you what do we benefit from having these volunteers reporting. This is what for most of the period from 1890 till more recently that a typical volunteer station looked like. This was an upgraded gauge with a plastic fiberglass top. I guess it's not fiberglass, it's plastic, and a stainless steel 8-inch diameter collector, and the old cotton region shelter, which have largely been replaced by the electronic sensors in the plastic radiation shield. But this is what much of our historic data have looked like, and it's amazing what value and uses and utility have come from volunteer observations when taken in a systematic way, distributed over practically every county of the entire country. It has become the absolute backbone for long-term climate monitoring, climate research, and climate service, i.e. sharing useful climate information with those who are affected and need to make climate-related decisions. Why so valuable? The reasons that the Weather Service's volunteer network has been so valuable has been its simplicity and uniformity, which is likewise why CoCoRaHS has become so valuable, sticking with a simple rainfall measurement using a consistent and uniform type of rain gauge. So consistency, uniformity, simplicity, key to long-term value and adherence to basic standards. Everybody trying to do things more or less the same way. The best source by far for precipitation and snowfall has been volunteer manual measurements as opposed to more expensive electronic automated measurements. The national extent and spatial density, that's what made the volunteer network of the National Weather Service so valuable, likewise making CoCoRaHS so valuable. Longevity with continuity, continuing over long periods of time. CoCoRaHS is still a young network. We're supplementing, filling in the gaps between the relatively distant spaced National Weather Service cooperative stations, which are typically 20 to 25 miles apart. And as we know, for those of you who have been taking observations and comparing your rainfall to those around you, 20 to 25 miles apart can be like a different world with many storms. And then metadata, I'm simply there referring to tracking, documenting what we know about the station, its instruments, its location, its observer, its times of observation, type of sensors, etc. Just tracking it over time adds value to the network. And then the fact that data are archived and accessible adds huge value. That was true for the cooperative network, likewise true for CoCoRaHS, and then likewise for both networks. Motivated participants and many users anxious to make use of the data that we're collecting. So how do we use the data from volunteers? There are so many ways and so many means. Let's look. Originally, prior to about 1940, World War II era, most data were used for agriculture, knowing what crops could be grown, where, when, early agricultural research, mechanization research, etc., and then looking at frosts and growing units and all the things that agriculture needed. But after World War II and during World War II, the uses suddenly evolved into much broader and often more infrastructure related. Architecture, engineering, transportation, communications, insurance, recreation, you name it, the weather data that are collected by volunteers are used. I want to show you here the inside cover of an awesome book, and some of you may have collected this or seen it in a library. At its time, it was the premier climate analysis of data collected by volunteers up into 1940, and it was sort of the culmination of the work of the Department of Agriculture and the U.S. Weather Bureau. But I'm going to show you several examples from it. Interestingly, much of the work for this yearbook was done by people hired through the Works Progress Administration, the WPA, putting people to work during the recession of the depression of the 1930s. And interestingly, some people got their start in climatology because of that. Here was the data points already used for the completion of that amazing piece of work from 1941. And you'll see that the cooperative network was already robust, and in some of those stations already had close to 50 years worth of data, enough at that time to give a pretty good idea of what the climate of the U.S. looked like. And this was the best annual temperature map generated at the time. And you can zoom into your favorite state and see the ranges. We're going to highlight some of Illinois in this talk because, number one, I grew up there, and number two, we saw that more people from Illinois registered for this webinar than any other state, although we had lots from Texas, plenty from Colorado, and somebody from almost every state. So we don't have time to dwell on each of these maps, but I'll let you know that they are available. We will post them afterwards, and they all came out of this amazing piece of work. This was the map of average January temperatures, and now I'm going to show you the latest. As of a couple years ago, we worked closely with the PRISM climate group at Oregon State University. Here was the latest 30-year normal map of January temperatures. Whoopsie, there's January as mapped in 1941. There's January as mapped here just a couple years ago, and you'll see some subtle differences related to where weather stations are. I'm looking and noticing that the coldest weather is shifted a little farther east into Minnesota instead of just in North Dakota and extreme northwest Minnesota. And you'll find, much more detail in the recent maps in areas of complex terrain, coastal, Great Lakes area, but it was pretty amazing to see how similar most of the analysis was. You'll also see we're a little bit warmer in this recent period than we were in that original 50-year period. Here's the analysis strictly for Illinois as drawn. They did maps for each state as a part of that yearbook in 1941 and had narrative descriptions, many wonderful resources. Then here is a blow-up from the PRISM map for the same period. Let's see, that was average January temperature. There's average January temperature more recently. Most similarities. Whoops, I'm getting behind. Then, oh yeah, there's the average annual minimum temperature. A lot of you are gardeners, a lot of you use plant hardiness zone maps. It turns out that's based on this number, just a single number, which is the average annual extreme minimum temperature. So every year you measure the coldest temperature that year, you then average it over your period of record, you then map that average. That was the makings of the early plant hardiness map, and this was this hugely popular PRISM-generated USDA plant hardiness zone map just created a few years ago. Millions of hits on the website for this product, and you can zoom in to your own state and your own county on the online product, which I guess I don't have the website here. We could find that for you. And again, there's the first, this comprehensive map of average annual precipitation as of the late 1930s. Here is the same updated map, and you will find so many things similar in these maps, just more topographic detail in the more recent map product. Okay, I'm not going to labor. Some of these things we can come back to, or you can at your leisure, but just want to give you examples of what we do with volunteer data. Yes, knowing the seasonality of precipitation. These are some areas of eastern Colorado that get most of their precipitation in spring or summer or both, and very little in midwinter. On the other hand, you go to California, and by the way, some parts of California have measured precipitation yesterday and more today. This is good news. You can see it's just barely the ramp up of the wet season there for California. But it's such a totally different climate. And that's, again, with volunteer reports, we can see the whole country and the seasonal distribution and how it varies and how it affects life and vegetation, etc. The old maps, they knew that precip just during the growing season was important for agriculture. They mapped that. The percent of years with less than 20 inches of precipitation, those were viewed from a 1940 perspective as crop failure years, or areas very vulnerable to drought, which of course the Great Plains fall highly into that category. And this was just following the Dust Bowl years, so they were very interested in these statistics at that point in time. Average number of days with 1/100th of an inch or more of precipitation. That's, by the way, something we compute in our water year summary reports. At the end of the water year, we got 2 weeks to go, and the 2015 water year will be at an end. If you're a CoCoRaHS observer, remember to get your records caught up by the end of the water year. But find your favorite place in the country there, and you can see what the average number of days with 1/100th of an inch or more, in other words, measurable amounts of precipitation. Looks like it ranges from almost every other day in the far Pacific Northwest. Did I see less than 10 days here in the Death Valley area? Florida, 100 to 140. Again, much of the East Coast, Great Lakes area in that 100 to 140 days of measurable precip range. Interesting stuff. And that's what we learn, and those are things that decision makers sometimes need to know. What about the most precipitation in 24 hours? This is something that has always been of significance for reporting flooding, for understanding the kinds of bridges and basements and all sorts of things you need to keep track of, is how much can it rain in a day. And you'll look at this product, and then these same products are being continuously updated, and your data from CoCoRaHS are important for this. The NOAA Atlas 14, a great new resource, not quite done for the whole country, but many states you can go in and find their 24-hour maximum with a 100-year return period, or a 50 or a 20 or a 10 or a 2. These are things civil engineers, stormwater managers, they're looking at these statistics all the time. Average number of cloudy days, killing frost dates. Again, we could talk about this for a long period of time. We don't have a long period of time. You can come back and look at these at your leisure when we post this online after the webinar. But this was as we analyzed it in the 1940s, and then products developed to look at it more recently. Once you have long-term data, and that's the marvel of the National Weather Service Cooperative Observer Network, and that is when you have long-term data from individual weather stations, you have the ability to understand variability and dig into things like climate fluctuations, potential cyclical patterns, relationships to El Nino and the Southern Oscillation, possible long-term climate trends and change. This is just a statewide analysis. You can get this for any state in the country, looking at precipitation or temperatures over time. It's all built off of the National Weather Service cooperative data. Without it, these sorts of products would not have local value. And then I love doing graphs like this, just to show the averages are useful, annual totals are good, but how it comes through the year is how it affects you and me. And it just shows you just how remarkably variable our climate can be and how different one year can be from the next, and the fact that no 2 years are ever alike, which is why it's so important that all of us continue our observations as best we can. Your data from CoCoRaHS and the data from the National Weather Service Cooperative Network are foundational for U.S. drought monitoring. This was the drought conditions as depicted by the U.S. Drought Monitor in the end of the summer, or during the peak of the summer of 2011, when Texas and Oklahoma, New Mexico were suffering in extreme to exceptional drought. 2012, that drought expanded to much of the country. 2013, the eastern half of the country saw relief, and that relief gradually worked its way westward. 2014, by end of last summer, still dry in the Southwest, and the California drought, of course, extremely established. But this is volunteer precipitation observations being put to use because they have such value. And then here, as of just a few weeks ago, the drought sort of teasing us again in some spots of the east, but mostly gone from the eastern 2/3 of the country, very present yet in the west. These are our observations at work. And again, over time, when you have continuity of observations, you can do long-term monitoring and trend analysis. For our part of the country, summers are distinctly warmer than they were, not dramatically. If you look at those numbers, it's maybe 2 degrees Fahrenheit warmer, but still that's significant in terms of many aspects of what grows and how much water it needs. The data from volunteers of huge value in anticipating and predicting and tracking the remarkable floods on the Missouri River in 2011, and then that same area dramatically reversed into drought the very next year. So many uses, so many opportunities. Yes, some challenges here and there. Volunteers, it's hard to keep going for decades at a time, and hard to maintain continuity. But keeping things simple, keeping procedures and ways of reporting easy, and ways of accessing the data straightforward, so many uses are possible. Just wanted to point out our own campus weather station, where we've done everything imaginable to try to do things in the same place, in the same way, for long periods of time, using the same instrumentation as decades ago. And we have this very profound, dramatic warming trend. Some of that is actual regional climate warming, but a whole lot of it is the change of the environment around our station. The first picture I took showed you from the 1870s or 80s was right in this area, and at that point that was the only building from there to the mountains 4 miles away. Then the station moved, and then it had to move again when more buildings were built, moved to here, and then had to move again when more buildings were built, moved to here, had to move again when more buildings were built, and there is where the station has been for the last 55 years. We have a little island of beautiful vegetation, but we're surrounded by buildings, trees. We have wide open to the west and southwest and south, but still, and because the next buildings are about a quarter mile or more away. But just telling you, your environment around your station will affect what you report. So much of the country, we haven't talked about snow. We're getting close to the snow season. I get excited about snow. Some of you don't. But if it wasn't for volunteer snow measurements, they are the best and in often cases the only source of snow data for our country. There is the national average snow map that we have been able to piece together thanks to volunteer observations. You can look on where you live and where you fit on this pattern. My guess is most people on the call today live in places that probably get less than 24 inches of snowfall a year. But there are probably a few of you who are in some of the relatively limited high snowfall areas of more than 6 feet a year, which is New England, parts of the Great Lakes, and much of the high to moderate elevations of the Rockies, Cascades, and Sierras. I had to bring in a grandson picture just to make it good. That's our little grandson experiencing his first snow angel a couple years ago, or yeah, only a year ago. Yes, you love snow, you hate snow, but measuring it is so valuable if you can. Just getting you in the mood so you're ready for another year of snow measurements, rah-rah. Ooh, don't measure here. Important use of data is detecting and predicting avalanche potential. Colorado is one of the leading avalanche states of the country. Stay out of their way. Don't let snow get too deep on your roof. This person is taking the appropriate precautions. Animals don't always care for snow, especially on the Great Plains where the snow and wind are synonymous. Travel in snow. Snow is to be enjoyed from the comforts of home and warm places, not on the road. But who uses our snow data? Transportation organizations, snow removal companies, utilities, etc. Amazing use of winter snow information. Heavy snow breaks trees. This was from our very serious snow a little over 12 years ago here in Fort Collins, with over 5 inches of water content in a 30-inch snow. So much weight in that snow that we had something like 300 buildings damaged or destroyed by the weight of the snow. And weather stations and weather observations are worth celebrating. We had a party at our weather station. There's me, I seem to be the tallest of the group, and some of the people with significant part of that's Nizette Riddell from the National Weather Service, and just folks came together to celebrate our weather station, our 125-year plus data collection, and there we are, people enjoying the ceremony, and then the tour of the weather station. There's the CoCoRaHS gauge, there it is. Those of you who have evapotranspiration ET gauges, there's our ET gauge. There's the historic National Weather Service standard rain gauge and the weighing gauge, and a snowboard in the background, the Fisher-Porter weighing type gauge, which has been now used by many Weather Service cooperative stations for about 30 years. And every station should have a plaque, don't you think? We were very proud of that. And so finally, as we come to a close where we can have a little conversation and talk about the questions you might have about volunteer observations, CoCoRaHS, where do we fit in? The fact of the matter is we fit in the gaps between all of those cooperative stations of the National Weather Service, and the gaps are many and the gaps are important. We wish we had a gauge every square mile of this country, and if we did, we would see even more variability than we currently capture with our existing network. We wish we had many more volunteers in many more places, but we're happy for the thousands of volunteers that we have. And for those of you who are interested in some of my farm stories, this was a friend visiting our farm. This is our old barn, and this is one of our horses right there. I believe that would be Missy Brown. Q, I didn't want that one. Oh, that's the one I wanted. All right, I want you to, what is that? What was the, Oh, yeah. Okay, skip that one. That's the one I want. I want you to just enjoy with me what CoCoRaHS, with your help, has been able to accomplish as we strive to fill gaps. Here we go. This was what we looked like right here around Fort Collins with the network as it existed at the end of our first complete summer, 1998. I'm going to just go through each year and you can watch what happened. 98, 99. Generally picking the same day, about the 12th of September. It's not always quite the same day. Sometimes picked another one nearby to find a more interesting rainfall day. There's 99. There's 2000, a dry day. 2001, so we're still just in Colorado. 2002, we're expanding a bit. Oh, that had been a drought year, but we had a rainy day in what had been a painfully dry year. Then watch what happens after 2002. We're expanding. 2003. 2004, we welcome Wyoming and Nebraska. Nebraska came in big time when they started their Any Rain program. There's 2005, more states coming on. 2006, welcome Missouri, Indiana, Maryland, Pennsylvania. 2007, several more states joined. 2008, 2009, and by the end of the year 2009, starting into 2010, CoCoRaHS had become a national network. And with that, we can now do national activities that we couldn't do before. Now, the National Weather Service Cooperative Observer Network is doing better, especially in the winter in Montana, North Dakota, Maine, etc., than CoCoRaHS. And they've done a better job recruiting the rural areas of Nevada. But we do what we can with what we've got. 2011, 2012, 2013, which for us, we were in the middle of an extreme flood event at that time, and we had more volunteers reporting than ever before. It allowed us to do exceptional, high value, high importance mapping of an extreme event. You don't ever know when that's going to occur. You just need to be ready when it does with your best possible 24-hour rainfall observations and significant weather reports. 2014, thank you, Illinois, Indiana, Michigan, doing a great job of catching that storm. And then I think I just showed today's map. Not all the reports were in yet when I clipped this one in. Welcome Canada, where we've been adding more volunteers on a weekly basis. But look at this, the very dry areas of Washington, Oregon, and California getting some rain. Yesterday it was the last 2 days it was Southern California. There's upwards of 2 inches here. My guess is we have several of you from Florida on this call. You had a big day for rain on the East Coast with upwards of 2 to, I think, over 6 inches on the East Coast. We will not have a lot of volunteers in this area, Lake Okeechobee, the Everglades. We'll let the alligators alone there. But thank you again. Volunteer weather observations are needed and utilized. That's the bottom line. And this is a summary graph that Henry put together, and I think this is the last slide, just showing you who are using our data. Weather forecasters, the National Weather Service, hydrologists, both NOAA, the River Forecast Center hydrologists, and many other organizations, other agencies, state and local. Water management, looking at both water supply and demand. A lot of researchers using our data and the cooperative network. Agriculture still cares as they estimate crop yield each year, which they do on a very detailed, complicated forecast procedure. Precipitation data is one of the biggest inputs. Climatologists like me using climate data from volunteers all the time. Insurance, engineering, recreation, so many others. The data we collect, the data you collect, the data other volunteers collect, so important and so appreciated. So with that, I want to say thank you for listening today. And Henry, I'll turn it over to you to take it from there.
Thanks, Nolan. Really appreciate you taking the time to to do the presentation today. We've gotten a couple of questions in, and if you have a question for Nolan on this presentation today, please go ahead and type your question in. Be sure to include your name and the state you're from. Earlier you mentioned about Ben Franklin being the Philadelphia and the National Postmaster. We have a viewer here who writes to us and lets us know that Ben Franklin was the Philadelphia Postmaster in 1737, just 5 years after George Washington was born.
Wow.
And then he was appointed Postmaster General July 26, 1775, at a salary of $1,000 a year, and that probably went pretty far back then, buying a lot of candles and quills and so forth. But well, let's go ahead and get some of the questions that are coming in, and we will put up the plant hardiness address and some other stuff on our webpage. If you have not had a chance to take a look at the climate guide for master gardeners on our CoCoRaHS webpage, it's very easy to find on there. Go to the left-hand panel, you'll see it. That goes through a whole bunch of similar slides that Nolan mentioned today on the frost, the freeze, the temperatures, and so forth. And please take some time to view that. Okay, here we go. And let's start off with, here's Janice writing, and Janice wants to know that she's a volunteer and she measures rain and snow, but what other factors would you like our volunteers to collect? So what other stuff out there as a CoCoRaHS volunteer? And again, that information would go in probably in the daily comments.
Well, many people have asked about measuring temperature, and quite a few people type that in. We have not chosen to make it a priority because it's a little harder to standardize, a little harder to have everybody on the same page doing it in the same way with appropriate exposure, and temperature does not have the magnitude of variations. It has variations, but doesn't have the variations that precipitation has. But we appreciate your comments about temperatures. We don't discourage them by any means, but we don't map them. Things that we really do appreciate is, particularly with the heavier rains, is a little more detailed comments like when did it begin, when did it fall heaviest, what sort of flooding was in your area. You'd be surprised at how your verbal description of the conditions that you've experienced are very helpful to those of us using the data. I find that almost 90%, at least 80% of the time, the person in the country who has reported the heaviest rain of the day, 6, 7, 8, 9, 10 inches, writes no comments whatsoever. And we're saying, oh, please tell us a little bit more about the storm. There may be the assumption that we know all of this, but we really don't. So documenting more details about the storm event. Then when it comes to winter precipitation, you're going to deal with situations where rain changes to snow or back. Please document additional information about when those things occur. Please submit significant weather reports in addition to your regular daily report. That's a huge help to the users of the data, particularly the National Weather Service and forecasters. And then, Henry, you might be thinking of some other things that, as I'm talking, I'm not always thinking. That observers might want to pitch in as well. Certainly, big, strong wind events that may have caused damage, nearby lightning that may have caused damage in your neighborhood, things like that. And then please let us know about hail. That's a big help to us.
Yeah, I remember a couple of years ago when there was an earthquake in Indiana, and a lot of people woke up that morning getting rattled by that and put that in. So you bet. Yeah. Okay, well, let's get to some more. We got a bunch of questions out here, and if we can do that, that would be.
Yep, I'll try to have quicker answers.
Okay, all right, here we go. So one of the question from Robert and also David, they wanted to know you didn't mention all the different volunteer networks out there. They mentioned CWAP and APRS, also the MPING NOAA has an MPing. Maybe you could just mention what those are and if our data is related to or integrated with any of those.
Yes. CoCoRaHS focuses on manual observations, but in this day and age, there's many opportunities for electronic data transfer. CWOP, it stands for the Citizen Weather Observer Program, and the other acronym you gave is one related to, I believe, amateur radio communications. Those networks which allow real-time online data from stations that are logged into the internet, so their data can be transferred on a very regular basis to the Weather Service. Those serve a different set of purposes, generally not climatological like the examples that I showed today, much more geared towards real-time weather forecast and warning applications. But those are what those networks consist of, which is those of you who have automated stations, linking them up to the internet and sharing the data with the large community that way. And then the MPing is an app that allows any person experiencing a form of precipitation to, based on your app or based on your location, you just say, you get on MPing, and I think, Henry, you've done that. I have not. If it starts to rain, you can say, aha, rain at this location at this time, or hail. It's fairly simple.
Very easy. Just on your phone app, just push a button, and it's that quick.
It doesn't give the details that we're able to give from our point locations, but it allows you to report wherever you happen to be at that time. That is predominantly being used by researchers at the down in Oklahoma at the big Federal Research Severe Storms facility there, as they attempt to get better at interpreting radar data and what it means in terms of type and intensity of precipitation. So good question.
Here's one from Robin in New Brunswick in Canada, and she's wondering about the CoCoRaHS entities there in Canada, or excuse me, CoCoRaHS data mining by Canadian entities is growing. Can you talk a little about the Canadian connection with CoCoRaHS and what's going on up there?
Sure. This has been an interesting and growing partnership. Began a few years ago with the remnants of what used to be the Canadian Wheat Board, which was, I believe, legislatively downscaled or something a few years ago, but trying to get better precipitation data associated with the wheat growing areas of the Canadian prairie. But then Environment Canada, which is the equivalent to NOAA in Canada, also trying to fill in the gaps between their relatively sparse first-order automated stations and their relatively somewhat similar cooperative network, volunteer network. But we've been gradually adding partner organizations, and there's a huge interest, and I'm forgetting the name of the sort of volunteer group in the Atlantic provinces that all joined at the same time. That was really fun when we saw that, and we felt for everybody up there last winter. All the attention in the U.S. was on Boston, but there were areas in the Atlantic provinces of Canada that were buried under even more snow than New England was by quite a bit.
Okay, thanks. Tommy in Virginia wants to know if we need fog reports.
Ooh, fog reports are distinctly useful, significant. Both, you can write them in your comments of your daily precipitation form, but also onset and development of dense fog is well worth submitting significant weather reports for. That is not something we focus on a lot, but it's something the Weather Service and other forecasters really appreciate.
Thomas has a question. He's from Sand Lake, Michigan, and he lives in a semi-forested lakefront area, a lot of houses around. He wants to know, when we set up for snowfall, what should we look for the best place due to the proximity of the houses and trees? So how should he do that?
Yep, finding the best place to measure snow. you often aren't sure until when the snow is melting, and then you say, aha, that's where I should have measured it. But you're looking for, you don't want blockage from trees, and coniferous trees in particular intercept a lot of snow and block it from accumulating on the ground. So you want to be in a relative open area, not too close to your house, because you will get roof blow off within a few feet in either upwind and downwind of your house. You're compromising because you want it to be a convenient place to measure where you can get to. If it's not convenient, you won't do it, but you don't want it to be too obstructed or too close to existing trees or buildings. It's something that with experience you can sort of determine where is the best place that I should have measured, and then make that your measurement point for the next snowfall season. But many of us don't have the perfect location. You do the best you can with what you've got, because your data will generally still be really useful unless you can tell that too much snow is being intercepted. We have some people who will measure right on the deck within a few feet of their house. That can be okay on a straight down snow, but if there's wind and drifting off the roof, it will cause some exaggeration or some opposite to exaggeration.
A friend of ours, Kevin in Maryland, wants to know how does the water year map of Colorado for co-op data compare with the CoCoRaHS data, and do you have a map that shows both data sets?
We do, and we don't do them separately. We integrate both CoCoRaHS and Weather Service co-op data when we do our climate monitoring and mapping. If we did each separately, which is a useful exercise, I think we would find that CoCoRaHS adds detail where we have denser numbers of observers, but the co-op network covers all areas relatively uniformly. It gives a little more smooth looking pattern, but it represents all regions. We do have a few places where we don't have CoCoRaHS observers, for example. But for the most part, if I looked at a map made from one or the other, they were both going to show you about the same things, and I love using both of them together because it maximizes the value.
Cynthia writes, and she wants to know, how far can a co-op station move to consider its record continuous before and after the move?
Okay, it used to be more liberal. It used to be you could move it up to 5 miles if the elevation change was less than 200 feet. But they've become more rigorous, realizing that smaller changes can have significant impact on the continuity of the data. They're now considered more on a case-by-case basis. In the plains area with no elevation change, I think they may still accept up to a couple of miles, but in any vicinity of coast areas, Great Lakes, or topographic changes like the mountains, if it's not within a much shorter distance and well less than 200 feet in elevation gain, it was going to be assigned a new station number now.
Gary, who moved recently from Wisconsin to Arizona, one of our former coordinators, also brought, as Elijah brought up the co-op network, said one other specific use of co-op and CoCoRaHS data would be for validation of remote sensors, radar and satellite, especially in data void areas.
I am so glad you mentioned that, because I should have had that as a slide. Remote sensing, both satellite and radar, heavily relied on for many weather and climate applications these days, but they're only as good as their ground validation, comparing to what's actually happened on the ground. And every single day, the data from the co-op network and the CoCoRaHS network are all being ingested and compared to remotely sensed data to improve those estimates. Thank you for reminding me to say that.
Dave writes, and he lives in Arizona, two questions. One is that how often does the CoCoRaHS gauge need to be replaced as the plastic starts to get crazed from the ultraviolet light? And also, he said he's willing, if you let him know where would you like to see new CoCoRaHS stations in Arizona, if he was willing to donate some gauges. So,
oh, that's fantastic. First, the gauge is getting crazed, is it? I think the observers may be. Hazed, I think, is a better word. And yeah, I don't like the fact that the gauges do degrade in intense sunlight. And as long as they do not crack, they can be used. But we see some of the gauges in cloudy parts of the country may last 15 years or longer, and in some of the very intensely sunny, hot areas of the Southwest, we're only getting about 5 years out of them, unless you do a little bit of, we have some observers who put a little UV cover on the sides of the gauge, and it does add to their longevity. But yeah, don't replace it if you don't have to. I wish we could give free rain gauges to everybody who's already bought one and measured for 5 years or longer. I just don't happen to have a budget for that. We are trying to fill gaps right now in northern Arizona, and we have some recruiting efforts there starting now, but we've already got a nice donation of gauges for there. Any place that's a mile or more from an existing site, even in urban areas, is good enough, and particularly any place you can find communities that are 6 miles or more from the nearest existing co-op or CoCoRaHS gauge, high value in adding those. So we do have areas of the Southwest where there are people living where we do not have volunteers. Thank you for that offer.
Scott from Las Cruces, New Mexico, he's presently a CoCoRaHS observer, and he collects and records rain gauge data. He was wondering, he wants to set up a full observational weather station in his house. How would he go about doing that, and what instrumentation should he obtain? And I will point out that, Scott, if you do set one up, please still do your manual observation with the CoCoRaHS gauge.
Yeah, and for those who think we're old-fashioned in wanting a manual plastic gauge, the manual reading is still viewed as the most likely to be capturing the most accurate reading. Automated gauges serve many wonderful real-time purposes, but they are not as consistent in performance in intense rains or in anything resembling frozen precipitation. In terms of equipment, it's wonderful to measure temperature, humidity, wind, direction, and speed. Finding an appropriate location where you can get above or away from obstacles makes the data the most useful and representative. And again, we love it when people do comparisons between their automated and their manual gauges. We probably have 200 or so observers right now who share occasionally the results of their comparisons, which is why we continue to encourage manual measurements, because on average the automated gauges are still coming in 10 to 20% low over the course of a year as a whole. They may seem fine on any given day, but they still average low over the course of the year. So those are the things. Barometric pressure, of course, is something that's a fun thing to look at locally. It's not, we view the data available from official sources to be adequate for pressure mapping and measuring across most areas, but for an individual, it's having that at their fingertips is really fun. You can spend as much or as little as you want. You generally get what you pay for when it comes for automated stations, and I'm not at liberty to give specific recommendations on types of equipment to buy, because we don't really, that's not our bailiwick.
Okay, Jim in Maine wants to know, you say the water year starts on October 1st. Should we start you routinely submitting zero snow accumulation starting on that date?
Well, I'm a purist, and I do it every day of the year. Obviously, we can infer 0 for most of the times, but we really appreciate when you make a positive report of no snow and no snow on the ground, and to do it for the primary, any of the months in which snow can climatologically fall in your area. And for New England, October would start that season. So yeah, it's a great idea.
Okay, speaking of New England, Scott in Rhode Island was wondering if there are any certification programs available through CoCoRaHS.
We have talked about that. It's sort of a barrier to participation if people feel they can't be an observer without first being certified. So no, we're not offering any certifications. The Skywarn program, National Weather Services, has a couple levels of training that they offer that comes not necessarily with certification, but with and again, our Weather Service friends could describe this better, but you do get recognition for the different levels of training that you've been through. We find that the best training for CoCoRaHS is on-the-job training, and the more years you've been doing it, the prouder we are of you, but we don't have a certification program at this time.
Nathan from Arkansas writes, and this could be for anybody out there. He wants to know, he works for a weather information provider. They have a weather social network. What are ways they and others can encourage more of their members to get involved in CoCoRaHS? Is there anything they can do in their local community to get people involved, such as schools, etc.?
Oh, we love it when local leaders who are aware of the value of what we're doing lead the recruiting effort in their own communities. We don't have, I mean, we have gotten national press a few times, and even if we had a big story on the Weather Channel, about the most new recruits a national news story has gotten us is about 20, whereas some well-positioned local publicity has sometimes scored that many volunteers from a specific county alone. So what's more important is the timing and the general audience, and some of the timing would be when a big storm is anticipated or has just occurred, and the value of local precipitation data and the variations across the area have been profound. That is often, it's the opportunity time more so than anything else that seems to connect us to the people who are then more likely to sign up. Also, don't be frustrated. We tend to think that one announcement and everybody will sign up. No, it often takes multiple announcements and then contact from somebody you know and trust. The Weather Service has been our biggest successful recruiter through their severe weather training programs and some of their web pages, but anything local that reaches a weather interested audience could result in new recruits, and we're all for it.
Okay, Nolan, we're going to take the last question of the day. And this is a good one from Tommy in Virginia. They're all good questions, I should say. But this is an interesting one. What is your prediction for the El Nino 15-16 winter?
Oh my heavens! I pay attention to that specific to my area of responsibility as state climatologist to Colorado. But of course, El Nino is a global phenomena, and its impacts are felt globally, some places with great or reasonable confidence, a lot of areas with a little bit of skill, and a bunch of areas with very little predictability. But because of the strength of the current El Nino, which is a warm pool of water off the west coast of South America extending out into the Pacific, the extent and magnitude of the warmth would suggest that we'll have a particularly strong response this year, and the response is one of more precipitation and cooler temperatures across the southern tier of states, dry in the Ohio River Valley, mild and dry over the northern plains and the northern Rockies. For my state, Colorado, it's more of a flip of the coin because we're in the battle zone between the wet areas to the south and the dry areas to the north, and it can go either way. California, relationship to El Nino is not as predictable as most people think, except in periods of very strong El Nino where the likelihood of heavier precipitation is better. So we're certainly hoping that that is the case for the friends in the West Coast. And it's good to see an early start to some precipitation already now there. So that's it. And for your area, I don't know. New England, Northeast, and the Mid-Atlantic, I'm not so sure.
Hey, we had one more question sneak in there, and this is a really important one. I think we should address. Diane wants to know that she's in an area where there are numerous reports around her from CoCoRaHS. Is there an advantage to having additional reports? So how close can people sign up, and do you need more observers?
And I'd be interested to know just how dense that area is. I know for me, I live in the most well-observed community in the country, which is Fort Collins. Probably the second most is Las Cruces, New Mexico. It's amazing to see. And yet, time after time, we will see differences so significant over distances less than 1 mile. I have a neighbor about 200 yards from me. We have both reported consistently for 17 years right now. We are fascinated seeing the differences between our two gauges, only 200 yards apart. So there, it's not like it brings a new data point that we wouldn't have any idea what was going on, but it makes the study of local variability all the more salient. So I would say for sure if there's a distance of a half a mile, that's big. A difference of a quarter mile can still be significant. And so yes, even if there's multiple ones in your neighborhood, if the people are interested and willing, and of course we have the mapping system that allows you to zoom in on it so that your data points aren't just masked as they are in our classic mapping system. So go for it.
Yeah, I notice even in my neighborhood that we'll get summer convective storms, and the entrance to our neighborhood, there's nothing, and I can pick up a quarter of an inch at my house. So again, it's very variable. It's great to have that out there. Well, Nolan, thank you for taking the time today, and also to everyone out there for joining us for this webinar. Really appreciate that.
Yeah.
Any last words? Any last words?
It was a pleasure, and I haven't done one of these for a while, and it was a lot of fun, and I just want people to know that what we're doing does have value, and collectively with multiple ways of observing and reporting, automated and manual, it's all the better.
And folks, if you will go, if you have a chance, take a look at our CoCoRaHS WxTalk web page. You can see that on our website, and we'll tell you more in a second here. Well, let me just tell you right now. Mark your calendars. The next CoCoRaHS WxTalk webinar, October 12th. I'm sorry, Thursday, October 15th. I got the dates. That's Columbus Day is the 12th. So this is a couple days after Columbus lands. At 1 p.m. Eastern for our next webinar. They'll focus on the southwest monsoon of the United States, and we'll have monsoon expert Chris Castro from the University of Arizona tell us about this fascinating subject. There's other ones on there, and you can see we've got them all the way planned through December right now. So finally, when you sign off today, please take the survey. That'll pop up on your screen. So until next time, this is Henry Regis for the rest of the CoCoRaHS team saying goodbye for now, and have a great afternoon. Take care.